Так, доброго дня, шановні студенти, колеги.
Добрий день.
Так, хочу вам представити нашого колегу з Гданського університету Якоб Древновський. Сьогодні ви послухаєте відкриту лекцію на тему. Доброго дня, шановні студенти, колеги.
Добрий день.
Так, хочу вам представити нашого колегу з Гданського університету Якоб Древновський. Сьогодні ви послухаєте. Так, все, передаю слово пану Якобу.
Добрий день всім. I will be continue my presentation in English.
І можливо, вімкніть, будь ласка, камери, шановні студенти, щоб ми мали уявлення, хто з нами, хто нас слухає. Лекція не буде довгою, тому це вас, не думаю, що введе за якісь проблеми. Ми б хотіли вас бачити, якщо можна. Продовжуйте тоді.
Так, я хочу вам запрезентувати мою лекцію, так, на воркшоп, на вашому демонстрації, так. Super. Dziękuję. Tak. I am now try to communicate into the English because my Polish, Ukraine, and maybe some Russian is not so good to present the presentation, and I am not know about especially technical words. In Polish Ukraine, maybe some words are similar, but it's too much for me now. But maybe for you also is good maybe to listen in English and to study a little bit and to know more. If it's something not understandable for you, maybe you want to ask or something, then maybe we can translate for. I am here in Kiev with colleagues from Ukraine. Maybe they will help you to understand if something will be not understandable. But today in the lesson, what I would like to present is a small workshop about the activated sludge models, about the past, the present, and future. Maybe about the past, I will not tell too much, but I would like to concentrate more on the present and the future, how we can use. I'm sorry about the phone. Okay. It's now it's about maybe before we start, I would like to say I am from Gdańsk University of Technology, and I would like to show how it's look like our university in Gdańsk, which is close to the Baltic Sea. We have also many young people from all around the world. Now we are also the part of European Union from more than 20 years. So we are very active in the Europe and also around the world, and we are traveling. We have a lot of programs which gives students allowed to go and study in different university, and that's time. This is a lot of change between Poland, but also between China now and other countries like United States or Canada. I was also in Australia, in Sydney. So we are trying to make our university more international, and the students are from all around the world. Also, there are some students from Ukraine, so you are also invited if you like to come. And this is my also work when I was in China last time. I also want to say that we have many people from China who are studying in our university also. I was also invited by Xi Jinping program in One Belt, One Road program in China with Xi Jinping, president of China, which is very, very nice. And I have some very big project, and this is all my students around. that we also do this project. So part of this, my work also is with IWA, International Water Association, and this is Young Water Professional. I am also the chair of the Young Water Professional in Poland, and we have also several meetings around this group. So this is also my third international active people, members who work with us and who are also exchange the knowledge. And this is also a huge program for also, if you like to join, I will also explain you how to do that. So this is a global, regional, and national. So if the International Water Association is all around the world, and many countries. It has 10,000 members, and also industry members, and also academic members. So it's very, very active in all around the world, and have a lot of conference. So you can check in our website, IWA website, how it looks like. And I will not maybe not explain you about this, but I want to say something more about Gdańsk. Maybe you know Gdańsk, maybe some of you be there, which are very welcome. The people who never been, it's very old town. History is over 1,000 years as a city of Gdańsk, but before also it was known in the Roman times, especially about the amber, because we are on the Baltic Sea. We have one of the beautiful amber in our region. In Roman times, there are 1 kilo of amber costs like 1 kilo of gold almost. So it was a lot of treasure there. So the Gdańsk looks like this now. It's very new, modern, and very also international place. This is the historical center. And this is one of our domestic market in Gdańsk. And maybe you know also that guy, this is the Solidarity Movement Lech Wałęsa. And this is our domestic market in the old city in Gdańsk. And our shipyard, the first president of Gdańsk was Solidarity, and he was fighting with communism. And finally, Gdańsk is now very famous that we were liberated because of this movement, Solidarity movement from communism, from the Russian times of communism, and the steel curtain was over, and we joined to the European Union. And this is our campus, which is quite huge. Everything is around. We have more than 30 buildings, different buildings. The main building is the most beautiful. It looks like a small palace. It's like this, and it was built in the times of Prussia in 1904, first as a school for the officers, and the University of Gdańsk. Then was changed by Royal Technical University of Gdańsk, and performed by William II, King of Prussia. At the beginning, after the Second World War, is Gdańsk, just Gdańsk University of Technology. And we have many faculties, over 20 different faculties: electronic, informatics, also electric, environmental engineering, which I am, civil engineering, and, nanotechnology, chemistry, lot of different, and also management, economy and management of ecology, different types of study you can try to find. And we also do many projects with industry, with business, and also with European Union project, with Norway project, and many academic research we have installed in our country and all around the world. So we also talk together about some kind of some proposition about the future cooperation between Kiev Polytechnic Institute and Gdańsk. So maybe you can be one of the part of the students who joined to this project. And this is our last conference in Gdańsk, which came people from all around the world, especially around the IWA Specialist Conference 2020 Removal and Recovery 2015 wetlands 2016 and about the odors in 2017. So last conferences we held in Gdańsk, which was very big ones, more than 300, 400 people from 55, 60 countries all around the world. And this is one of the people who were awarded in our conference from India. He has a best presentation and he was awarded. And I also, as a start of my career, I was also a member of IWA, and I also get as a student, PhD student, some financial scholarship from IWA. So it's also worth to be in these conferences. Sometimes you can get some kind of invitation for next conference, and I get a free come like to the conference to the Australia, to Sydney. The government of Australia and IWA make a financial scholarship for people who are the best presenters and best presenters. And also I meet a lot of people in the around the world during our net of members, Professor Mark van Loosdrecht from Delft University of Netherlands, Professor Daniel Mamais from Greece, also in Sydney in Australia. I meet some people from at that time, and also the opportunity to be IWA. It's a lot of opportunities. Thank you for small attention about as a student. I would like to show you some my career to show how it's looked like. You can also see IWA opportunity to have books and journals in English, especially water research, water science technology, which are very important journals in and many people, even people who are nobles, have some papers there in this journal, so they are very famous. So now, thank you for your attention. So I want to say about the nutrients in optimization of biotic and nutrient process, which is also, I was also in Tongji University in Shanghai, and we also present this there, and also the past and future of activated sludge modeling, because this is all very near, very close. First, the problem is the budget. First is pollution and the energy consumption. We have to balance between these all of things. And first, activated sludge modeling was very simple. We have activated sludge number 1, number 2, number 3. Maybe you know about this. It was set in this age of 19th, and then was the computer very big new solvers, new solutions for mathematical computer modeling. When computers make more powerful, in 90s, at the beginning of 90s was still weak, and we have only very simple solutions for mathematical computer modeling. But the group of people from IWA, International Water Association, was a task group who set and who designs these models. I hope you know about the models. If you don't know, you can also find ASM, activated sludge models, and there is also many information in the internet. There's also some book. I can also share with you some book about this, when you can find how was the history, because to say about history, I cannot do this in the half hour. It's a lot of information, but I want to say some give you some tips how to use these models and how we use now in the present time and in the future, what we can do with these models, what we expected, because the computers are more and more powerful. So we are now concentrating on the optimization wastewater treatment plants, because we know many things about wastewater treatment plants. We have this kind of processes, activated sludge process, for more than 100 years. The first time when was designed and was first time was used activated sludge was in England in 1914. So now it's over 100 years. We use this technology all the time. And this technology is quite well known in all of around the world, and biological treatment of the wastes in the wastewater treatment plant have a different modification, but still they need to be optimized, because we used a lot of energy for example, kind of different kind of processes, especially nitrification process and oxygen can be reduced, and different kind of wastewater treatment plants has this problem. And we used some kind of programs like GPSX. This is the one of the program for mathematical modeling. We have also the SAS, WEST. Also, we use sometimes MATLAB. MATLAB is one of the simplest one, but the other ones programs can have a lot of, like GPS6 can have a lot of icons. Maybe you can go also for this after this lessons, after this workshop. You can go to the website of GPS6, and you can find that this program you can use, and you can try for free, and you can see how it looks like. Each of the processes, like aeration tank, aerobic tank, for example, anoxic, anaerobic, or primary clarifier, secondary clarifier, you can have like icons, and you can optimize, and you can project your own wastewater treatment plant. So if you have enough data, you can have and project all the wastewater treatment plant in the one program. And there is a lot of equation using the activated sludge models, this historical activated sludge models, or 1 or 2, or there are new, some kind of newest activated sludge models like Mantis, which can also not only use such area like a bioreactor and activated sludge, but you can also construct a whole wastewater treatment plant using that models. But the main problem now we are looking and we want to optimize is the aerobic phase in the wastewater treatment plant, because this is the most energical point. We have a lot of biodegradable substances which is going to anoxic anaerobic phase, and they are using. We also have to optimize sometimes primary clarifier if there is, but we many times have to concentrate. To concentrate on the reactor, we have to have online measurements and diagnosis how this biodegradable substances, how this processes works, especially anoxic, anaerobic, and what is the level of nitrogen and or ammonium in the oxygen. Then you will see that aeration, it's like 50% or even more sometimes the other processes. So this is a very big costs for all this wastewater treatment plant. The power for other processes is not too big if you compare this one. So this is a lot of money. This is a lot of budget that we can save. So we are looking for also new kind of processes that can be shortcut nitrification, like deammonification or others that can be installed in the wastewater treatment plant. So the first is the problem, the main goal in controlling wastewater treatment plant and controlling these kind of processes is also variable influence. So there are disturbance between the wastewater which are going into the into the waste treatment plant, the effluent requirements, environmental aspects, economical goals in gains in investments in the wastewater treatment plant. We need to have economical gains in operation, energy, chemicals, which we can want to have in the wastewater treatment plant. Process complexity is very difficult, process safety and stable, and the service safety. It's also very important. So for this, sometimes we cannot do this on the wastewater treatment plant in the big scale. So we want to, sometimes we need to do everything, all this study in the small scale or laboratory or some kind of pilot scale. And based on this research, on the literal data, on our knowledge, we can have some kind of aeration control strategies for low energy process and removing nitrogen from wastewater. And in Poland was designed also, and we developed some kind of full-scale biomass process for large wastewater treatment plant in Gdańsk. And this novel model algorithm using activated sludge models procedure was based on our batch test, and also we do some tracer test in the bioreactor, in the real bioreactor in wastewater treatment plant. And independence of chosen technological parameters, activated sludge concentration, or DO, so dissolved oxygen, set point control, intermediate aeration, temperature, pH, also solid filtration time strategy, and also the location of DO NH4 probes. Everything was studied to make the more optimal process. So implementation of the full-scale wastewater treatment plant model, we are testing also the implemented model on the aeration strategies for low energy, and we also create some kind of support operation system, SOS, support operation system, which were developed based on our knowledge from other also wastewater treatment plant Klimzowiec from Poland. We calibrate this model. We introduce this model to the new wastewater treatment plant in Gdańsk. We adjust under real conditions, all these real conditions, and we are creating, this is the GP6 program, and we created a bioreactor, qualifier, and some kind of our control system we created in the program. So we simulated all these different strategies, points, and strategies, how to say, parameters of nitrates and nitrates, free and anoxide ammonia, soluble orthophosphates. So you can see that the points are real points of we measured in the bioreactor, and the other here they are how to say, simulated from the program. Yes, that these lines are simulated from program. So the points and the lines are very similar, except some kind of maybe some points which were maybe badly how to say, measured, because also the we can do some kind of we can do some kind of mistakes, and also because the model never is 100% the same, it cannot be this 100% as points, but we can see that the trends are similar. So it's mean it is a day, 1 day, 2 days, it's 5 days of simulation during the process. So we do the on-off controller of DO and ammonium, and PID controller for dissolved oxygen, variable on-off, variable ammonia. And ammonia-based aeration control we were trying to use as a model. So This is the panel of GPS-6 simulator platform. It was a 6.4. Now it's a new version 7 and 8. Even 8 now it's going to be introduced in the new year, in the next new year. So this is the panel. So in the first panel, you can put the input data of all your data you are interested to simulate. And then you reflect your own real wastewater treatment plant, how it look like, what is the points you want to simulate. Then you will have your simulation results, and you also have to fill the sheet of the influent advisor. Influent advisor, you need to have the parameters of the influent of the wastewater, but the most important, which are usually doing in the laboratory, and the other points are because of equations, they are calculated automatically by the program. And then you will have some kind of total COD and also the bio different others of total COD substrate, slowly biodegradable substrate, readily biodegradable substrates, or no biodegradable substrates. So this is also important to introduce in the program. And we have also some kind of batch tests. As you can see, that we can simulate a lot of data which are needed for modeling, and batch test and activated sludge models simulation. First, because we cannot do everything in the wastewater treatment plant, because it's too big scale and we cannot have a positive or sometimes enough knowledge what is about heterotrophic organism, what is autotrophic organism, what is a phosphate accumulating organism, because the program needs some kind of special have a special equation, and needs some kind of special data that we have. Some symbols of this data we have here about the growth, especially the speed, the growth of heterotrophic organism. We need to check it first. So we take activated sludge from the bioreactor, from the wastewater treatment plant, and we have this kind of simulation base. This is our setup. This is a laboratory setup. There are 2 batch reactors that we can simulate it. We can do all these kind of different parameters what we like. So we can use specific temperature, specific PhD, specific aeration program, specific and specific redox. So all those this information what we have in the wastewater treatment plant we can use and check in our laboratory simulations. In the laboratory simulation in this laboratory setup, and we are interested in nutrient utilization rate, phosphorus reduction rate, and anoxic anaerobic phosphorus utilization rate, and oxygen uptake rate, or it is ammonia uptake rate. So all of this special information we can then we use a laboratory. This is our previous study in Schut and the Mogurze wastewater, from 2 kind of wastewater treatment plants. We check before we do the simulation how is the special this is the default, and this is we do the calibration around these results from the batch tests. So the batch tests you can see are very similar to the simulation. The batch test results is a points, and the simulation is a line of these processes that we have in the batch. So nitrogen uptake rate, phosphorus uptake rate, or aerobic oxygen uptake rate. So this is all of them, and because we check our model on the laboratory base activated sludge, we can use the same calibrated points, the same calibrated data to the real model, to the wastewater treatment plant. So we use this in our first, as I said before, in Klimzowiec, in some kind of wastewater treatment plant in the south of Poland, and which were previously. We have also a lot of data from online from wastewater treatment plant, and also we have a lot of data from these batch tests, because I didn't say that this all data also are checked in the temperature, online pH,D, oxygen concentration, everything. The computer, there is a computer who save the data, and then we have a lot of data also online that we can also introduce to the program, and we can check also if there is the same kind of condition in the wastewater treatment plant that in our bioreactors in the laboratory. And we use that online system like ammonia probes, NO3 probe or NO2 probe. So we have here. And this real data from wastewater tracer test, we do the model calibration and validation. So the validation is the next step. So first we have to calibrate it and then validate it in the real wastewater treatment plant. Because for real, this was the complex model for wastewater treatment plant that we validate. So you can see how many objects they have. So first we do the biological reactor, which is conventional identification process. And then when we've calibrated and validated, we can introduce a new kind of things like this is primary qualifier, secondary qualifier, and other different processes in wastewater that we can do all the complex model. So now is a future of the models, not only activated sludge. So now we are going to the future more, because we are looking for some kind of models which can be used all of the processes in the one program. Yeah? Now we have this program, but still we have some problem to introduce and to how to say control all of the processes in the one system. In the now reactor, this biological reactor, it's very well known everywhere. It was a past and present what we are doing now, but for energy consumption and for control complex model of wastewater treatment plant, it's future, because we want to use this complex model to control all wastewater treatment plant in the real. That, for example, when some kind of reactor to save energy for reactor for aeration control, but also to aeration control, we need to know how much before we start here aeration control. We want to know how is the wastewater treatment plant influent, and how we can, for example, divide, or how we can concentrate the primary qualifier to have special substances in the qualifier. For example, the more biodegradable or not biodegradable, how long the qualifier needs to work, that we have the optimal condition for the reactor. So that's why we want to create this whole model complex, and this whole model complex we are testing now. But in our in real wastewater treatment plant, and it's going. Yeah, we have some data, we can use it, but still we don't know how to use this model in the real condition, and automatically how computers can do some calculation before they can try to introduce a new kind of condition for wastewater treatment plant. So we know how to simulate in steady state, but we don't know how to simulate in the real condition in online. Still, we try to find the way, we try to find which is the critical points, and we start some kind of new strategies. So this is like a future work. Maybe also for you as a student, maybe you will be interested in this. How to, because only calibration and only validation the models, we now use some kind of new kind of models like Mantis 2, which are more advanced models than activated sludge models, which were previously, because previously models only concentrated on bioreactors. And this Mantis 2 model, it's a new model which concentrates on whole calibration of whole wastewater treatment plant, not only bioreactor, but all of them, of complex. So you can have all wastewater treatment plant in one program. And this is the main goal now, how to use that. Because for us, now it's quite simple to use that model, for example, and looking for optimization. So we do some simulations, like you can see, and in different oxidation zone. In aerobic zone, we do some simulation between 1 and 0.5, 2 and 0.3, 3 and 0.4, and different oxygen concentration. And we can see that it's not important sometimes, because sometimes the people think that, oh, especially the people on the wastewater treatment plant, they think, oh, we have to put a lot of aeration to have a good results of nitrogen, especially total nitrogen. They are interested to go down and nitrogen during the nitrification zone. But our simulation shows that it's not so kind. This big, even sometimes too big aeration is going to have more and more problems with nitrogen. Sometimes it's better to have optimal, and also you save money. As you can see, the total nitrogen can be even lower. Here is below 10. It's not so big difference, but but the difference is not so big in total nitrogen, but it's a big difference in the cost of nitrogen. If you have 3 or 4, you will use a lot of unnecessary money. You will just, for example, if for big waste treatment plant, it can be millions of euros for 1 year if you use a lot of aeration. So you can save 1 million euro, for example, if you use such small, but you do this, for example, intermediate aeration, or you use a small amount of aeration, and you have even better results. Maybe not very big difference, but lot of difference in the real money, in the costs of wastewater treatment plant. And we also implemented some kind of dynamic model. As I said, it is the future now, but we created some kind of using very powerful computers, PLC driver and PLC model, into the wastewater treatment plant using a SCADA. SCADA is a system which is used in whole wastewater treatment plant, and we tried to use and operate it and control the SCADA through the model. The model are calculating the best, the best optimal results. But now, of course, we cannot use for whole wastewater treatment plant. We started step by step. So we started from bioreactor. So we use this as a process in the bioreactor, in conventional identification process, and use that feed forward or feedback forward. We also try to concentrate it on some problems from which are some kind of bad results from some, we call it noises, bad results from the ammonia or DO control probes which are installed, because we need to have online system all the time, have some kind of new information about the results in this process. So we have also some disturbance. We have to also know about that, because some kind of disturbance, sometimes DO probe, they have activated sludge, and activated sludge is glued to the wastewater treatment probe, and then the probe is not going well, or the same is with oxygen probe. And then, for example, oxygen probe can give you a bad results. For example, normally you have 0 aeration, and on the probe, in fact there is a lot of air inside because the probe is not working because it's glued by activated starch. So it's also some problems that we see in that. So these noses, which are very sometimes we see that noses like here, it's something is going to bad, not a normally trend, it's going bad. So this model prediction, this is a model prediction, and online measurements also give us information that something is wrong. And for example, it is the signal for wastewater treatment plant operated that it have to be maybe they need to wash up or clean up the probe, the wastewater in wastewater probe, and then when they clean up, you see the trends is going similar again. Yes, so this is the measurements, and this is the calculation by the model, and the model is sometimes predicted better than the probe, because the probe is still not good because they have some problems. Sometimes we switch and we don't use real measurements because they are badly. We use the model prediction, which is better. Yes, and here is our idea how to use it. Yes, we have some N2O probe, we have forward control, we have also some maximum criteria of DO controller, which can be, we have to optimize, and we are trying this model in the future to make more complex system for whole wastewater treatment plant model using this simulator GPS6. So this kind of optimization we are doing now. This is real system premises which are installed in some wastewater treatment plants, and you can see that sometimes there are interactions numbers, how they do to have the best value of results. This is the flow of, for example, mixed trigger in the bioreactor. This is the flow of waste activated starch and recycled activated starch, because all of this flows have a strategy point for optimal the aeration and the whole bioreactor. And this is some kind of examples of model predictive control and how much energy we can save. So this first is scenario is without anything. So you can see how many energy without any control of model prediction we have on the wastewater treatment plant. And this is a scenario with different strategies we use using energy control and using the model. So minimum 15%, maximum 20% we can save using this new kind of model predictive control only on bioreactor, only on aeration. So in the future, we can install it for whole wastewater treatment plant, probably this model, and maybe we will save more energy, maybe 30%, maybe even more. And you can see how much the trends of this is several hours we do, like 48 hours. So the trends of the model, it's and the trends of real of the probes are going very similar. Yes, so this is online probe model, which we use the data for this optimization of wastewater treatment plant. So this is also all international work, not only by me, but also our colleagues from International Water Association. And I would like to say that how much money in total in different wastewater treatment plants in the world we saved till now. We also we are fighting for, and we are looking for wastewater treatment plant which will be produce energy, or not only save energy but produce energy. So we are not net zero, not only net zero wastewater treatment plant, which produce enough energy for themselves, but also because of the savings, now we see that we can do also the savings. So that could be more than net zero. That could be also wastewater treatment plant, which will be produce energy. So not only energy, but also recover of different kind of from waste. We can recover different kind of how to say different kind of substances, like phosphorus we can recover, like nitrogen. So this is a new trend. Even in now we say that the wastewater treatment plant, it's not wastewater treatment plant. We say that wastewater treatment plant in the future will be the name, you know, the new name of wastewater treatment plant. Wastewater treatment plant in the future, in our colleagues in the International Water Association and all around the world say that wastewater treatment plant will be like a factory of the energy and the recovery of substances, because substances in the world are, you see, are so not enough. We have the sources of phosphorus, the sources of different minerals, the sources of gas and oil. We have only that we have in the we cannot produce any some kind of synthetic and minerals substances. Sometimes that is the way that we also use these new trends to first to save energy, second to find the way how to recover. So the next name of in the future, even in present, so many universities use in present time, that is the waste recover and reduce system. This is the WARF. The new name. It's a different name. So I only want to say that it was shown that in this kind of wastewater treatment plant, the well-calibrated and validated model within any studies and within the studies can be a very good point for evaluate process capacities, evaluate optimal changes in the wastewater treatment plant under the processes. And also we have more confidential in the model simulation now, because we also do the previous research, the previous studies. We have data. We increase the degree of the calibration we conduct. And also you can see the projects under realization. Some projects are on the first month that they installed such systems in, for example, in Wessex in England, and only from our study, only we find out that 15–20% we can save, but other processes in Sweden, even they save 30%. So you see how much millions of dollars can be saved. Also, this is the saved only on the processes in bioreactor, but you can see how many millions of dollars it was saved, like even 70%, when they want to modernize it. In Toronto, I was in Toronto 2 years ago. In Canada, they want to modernize the wastewater treatment plant. A first budget for the modernization was $220 million, and actual costs after they do the modernization, the simulation. So the simulation and the computer modeling using the activated sludge models can give information how much we can save, what we don't have to specially model, because they wanted modernized first all the wastewater treatment plants. So they want to destroy all of the wastewater treatment plant and build a new. But after upgraded by the models, they find out that some processes, that some kind of different instrumentation, different places in the wastewater treatment plant that can be don't have to be destroyed. They can use it, but they have to be optimized. They optimize this, and they don't have to build a new one, just they modernize it. So they saved $70 million. So even 70%. So they saved more money. So actual cost was $70 million. So they saved in your state in England, it was 60 million. So 25 million, the actual cost was on this modernization of it. So you can see that this kind of processes can be used in both ways, modernization and also for the study of actual processes. And this is one of the last thing I would like to say. I would like to say that, of course, the models are very, very nice and we can control many things, but the problem is this noise, that even if you have a lot of points in the wastewater treatment plant that you can measure on lines, because now we have a lot of different kind of probes that can be installed. Sometimes there are missing points, sometimes there are noise, there are disturbance, and this kind of problems we also have to, we cannot trust only this kind of parameters on the on these probes. So model can also help and also be installed as a controller, of sometimes there are missing points. So these points can be simulated by the models if you have a good model. I show it before. Yes, we have a problem with some kind of stabilization of the probe, and the model was the trend was going similar, stable, because this kind of disturbance can also be disturbance on the activated sludge in the bioreactor. So this activated sludge can you can be more stable and can be stabilized by the model, even if some probes are not going well. Sometimes the probes are broken. You have to change the probes, and you don't have another probe because they are expensive to have them. You need to wait for service, and if the service are coming in 2-3 days, the processes can go very bad in the wastewater. So also these 2-3 days, you can, the model can be kind of the model can have can be control the wastewater treatment plant DO, for example, points, and simulate these DO points to have stable process in wastewater treatment plant. So this is how we can use it and how the disturbance can be in the real in real hours. You can see also in here. So because of that, we have also virtualized this data. We use it, the name virtualized. So if the sensor are cleaning, the sensor are need the calibration, it's not going well, then the model is virtualizing the data, and we have still the optimal condition in the wastewater treatment. Also, it's good for diagnosis the system, because if it's something wrong, we see too much difference between model virtualization and the probe. We can be sure that it's too much difference. It means that it's something is wrong. So this is also like a diagnostic system. They can be diagnostic. So we can also know that something is bad with the wastewater treatment plant. If something is going bad. So the conclusion now is the innovations idea to use the mathematical modeling in diagnosis, in the control of waste treatment plant as an important development, and commercial software was used to build the model of the waste treatment configuration and for the dynamic simulation of the vertical processes. Such system allowed the operator of waste treatment plant to unload the objects, because it doesn't need the monitor operating parameters or the object in order to diagnose abnormal processes. That's what I said before. And also each of the measurement points could be diagnosis on the basis of individual roles during the diagnosis of the sensors. The rate of the measurements value change in the measured value according to the daily cycle, and also shown also be taken into the control. Also, the implementation of the special system and the appropriate communication software with SCADA is a further step in the development of mathematical model for the diagnosis of wastewater treatment plants, that I say. And now this technology is still developing and should be continued in the, as I said before, to improve as a part of future smart control system at the wastewater treatment plant for energy neutrality of wastewater treatment plants. So that is the main goal for us to find how to use this system for all of the wastewater treatment plant. So thank you for your attention. I hope to see you maybe next time in Gdańsk. Here's my contact, and also this is the last conference before the COVID we have in Toronto, in Canada. Future water leaders, I also invite you to join. Because of the COVID situation, now we have more online. So you can also be the part of Young Water Professional online and use online as a system and be the part. But maybe when COVID is over, we have another conference here in our region. The conference in our region, it's, I know next year it's planned to be in Riga, no? In Riga with Marina, no? It's in 2000 years in Riga, in there. So this is my contact. So if everybody has some kind of IWA Poland, and this is my email address to Politechnika Gdańsk, and also our webpage. So if you want to have more information about this conference in our region and want to join us, you can contact also to me or to our colleagues on our webpage. So thank you again very much. Maybe there are some questions to this presentation or something it was not something you don't understand.
Yeah, I have a question. You talked about this dynamic SCADA model. What is the main problem and why there is such big difference between the computer model and this dynamic model?
You mean about this computer model in the, for example, laboratory scale, yes, pilot scale, and the wastewater treatment plant scale, yes? This is the main goal, yeah. This is the main problem, yeah. I think it's a very good question because we still have such problems. We don't know yet how to validate it, because we know how to calibrate it, as I said, yes, it's easy to calibrate it in the laboratory scale, in pilot scale, in wastewater treatment plant scale. But then how to validate it from laboratory scale to the real wastewater treatment scale? It is the main problem. So this is the difference sometimes. And even if we have very good calibrated model, we do the same activated sludge in our laboratory from real wastewater treatment plant, it's a problem. Then when we implement it in real wastewater treatment plant, sometimes we need to validate it. So it's mean because on this condition, when it's in the wastewater treatment plant, we see that activated sludge in the real condition, they have probably much more different parameters that we can, you know, do in the laboratory. Probably there are more problems, more how to say local parameters inside that have to be also taken into the consideration. So many times that is the problem, and that's why we have to validate this model again in the real condition. Yeah, this is the problem.
Thank you.
Yes.
Yes.
Thank you very much.
If you have a question, you may write to Larissa Andreevna, and maybe we take it to Jakub from next time.
Yes, so please write to me an email. I can also give you the answer. So
yes, we have Tapas we can write this, record this lecture, and you see in YouTube this in all time if you want.
Well, thank you very much.
Okay,
Thank you.
Thank you.
Thank you.
Bye.